How are you, students? I hope you all are doing well and finding interest in this chapter, electricity. So, almost we are at the end of this chapter, and lots of things we understood in this chapter. We started with the electric charge, we did the electric current, we did electric potential, potential difference, Ohm's law, series parallel combination, and at the last we did the heating effect of the current. So, we understood when the electric current is flowing through a conductor, then heat is produced in the conductor, and the same concept is being used in making different appliances. So different electric appliances are basically working on the same concept. That is what we are going to discuss today, that is applications of the heating effect. So I hope you will be finding interest, and at the end of the class today we will talk about electric power. So today we will just have the introduction of electric power, and the same we will continue in the next class because it has derivation and numerical also. And then almost the chapter will be over. We can have some numerical practice, and then we can go for the next chapter very soon. So I hope you are able to do the numerical from the different topics of this chapter, and if you are finding any doubt, any problem anywhere, I'm always there to help you. So just let me know so that I can help you in the problem. So let's start the class today. So the topics we have today are applications of heating effect of current and electric power. So today we will just have the introduction of electric power, but we will do the applications one by one. So let's start with the applications of the heating effect, and the very first application we have is fuse wire. So you might have heard about it and you have done in class 7th if I remember. So the very first you can see the circuit diagram. There is a battery, there is a switch, a fuse and a load. So load is any electric appliance which is connected in the circuit, and in series with that there is a fuse wire. So you can see in the circuit diagram the fuse is a conductor which is basically connected in series with the circuit. Okay, so that is how we have to connect the fuse wire. So very first you should know this is how the fuse wire basically look like, which is there in the market, but there are different types of the fuse wire that I'll show you very soon. So it is a safety device which breaks the circuit when current in the circuit exceeds the limit, and hence prevents the appliances from getting damaged. So the concept is the appliances we have in the circuit at home, they have different requirement of electric current. So in the main circuit the electric current can increase, can decrease, and if the current will exceed the requirement of the appliances, then the appliances can get damaged, because that cannot be tolerated by the appliances. For example, if the current requirement by a particular appliance in the circuit is just 1 ampere, and if the current becomes 1.5 ampere in the circuit, or even if it is 1.3 ampere in the circuit, then that will totally damage the electric appliance. So to overcome this problem we need the fuse wire. So it is a conductor which is basically connected in the circuit in series with the appliance, and it has a low melting point, so that if the current exceeds the limit, then this fuse wire will melt because of the heating effect, and hence it will break the circuit. And once the circuit will break, the appliances will get prevented from getting damaged. So this is how the circuit, you can see fuse wire is connected with the live wire. Live wire is the main wire of the circuit that we have at home, that is basically red in color, that we'll discuss in next chapter, not to worry. So fuse wire is basically connected in series, and that is connected with the live wire, and once the current will exceed, what will happen? This will melt, and hence once it will melt, it will break the circuit. So it is just a safety device. Now different material is used for fuse wire. So very first, the material we are going to use for the fuse wire should have low melting point. If the melting point is high, then it will not melt and break the circuit. So based on our requirement, how much current is required in the circuit, we can select the fuse wire, and different fuse wires should be connected with the different appliances also. So very first it should have low melting point. So different examples you can see here, like the material which can be used, like tin, lead, silver, copper, zinc, aluminium, And the alloy of lead and tin can also be used to make the fuse wire, because these materials have quite low melting point as compared to other conductors. So this table just showing you the melting point of different material in degree Celsius. Like for silver is 980 degrees Celsius, tin is 240, zinc 419, lead 328, copper 1090, and aluminium 665 degrees Celsius. So you should know the normal copper wire that we use in the circuit, even that can be used as a fuse wire, but for that we need to take a very thin wire of copper. So by adjusting the thickness of the copper wire, we can convert it into a fuse wire also, that you should know. So in the market, different types of the fuse wire are available. You can see the diagram, the pictures shown to you. So you can see how the fuse wire looks in different shape and size, and based on the appliances that we have, we basically select the particular fuse wire. So I hope you understood this much. Next thing is rating of fuse wire. Rating means I have already said, like in the main circuit at home there can be current of 1 ampere, 2 ampere, 3 ampere, 4 ampere also. But for example, the requirement of current of the television is less than 4 ampere. For example, it is just 1 or 2 ampere. Then it should have a separate fuse wire, so that if the current will exceed beyond 2 ampere, then the circuit can break and my television should be prevented from getting damaged. Okay, so based on our requirement, we can have different fuse wire of different rating. So what is rating? A fuse rating is the current need to blow or break the fuse wire. So rating means it is the current at which the fuse will melt. So this rating is basically given in ampere. So the fuse rating is usually defined in amperes. So this is how it looks like, the chart I have shown to you now. So for example, the very first fuse wire is of rating 3 ampere, that is pink color. So if the fuse wire is in pink color, means it has the rating of 3 ampere, means 3 ampere may not be written there. So with the help of the color also, the color of the fuse wire, we can identify the rating of the fuse wire. So for example, if the rating is 3 ampere, means if the current passed through this fuse wire is 3 ampere, means if it will become 3 ampere, then this will melt. So this fuse wire will melt at 3 ampere or break the circuit at 3 ampere. Orange 5 ampere means it will break the circuit when the current will become 5 ampere. Okay, so if we need the current less than 3 ampere, then what can be done? We can use the pink color of fuse wire, and based on the requirement we can go for different fuse wire also. So that is how rating is to be understood. That is, every fuse wire is having some rating that is given in ampere. Next we have filament bulb. So the bulb you have seen at home, and even the torch bulb you have seen, that bulb produces light, and this light is nothing but because of the heat that is produced by the filament. So the filament only glows and produces the heat. So that is just based on the heating effect of the current. So the filament is the part of the light bulb that produces light, that we know. So this filament is basically made up of tungsten element. So very first, the filament which is there in the bulb is nothing but a conductor which can produce the heat, and that heat is finally converted into light. Okay, so for this we need to have some unique property of the conductor which is connected there in the bulb as a filament. So the first question that comes here, that why is a tungsten wire used in the filament of an electric bulb? So why only this tungsten and not any other element? So you should know the very first, that is, it has the highest melting point of any metal greater than 3400 degrees Celsius. So one thing we know, if we have to convert the heat into light, then the temperature will be very high. So that much temperature should be tolerated by the conductor without getting damaged, means the conductor should not melt at that much of temperature, so the melting point must be higher. So this tungsten has the highest melting point if you compare all the metals, and this melting point is 3400 degrees Celsius, means this much temperature can be tolerated by this without getting melted. Second thing is, we know the maximum heat can be produced by a conductor if the resistance or resistivity is high, because the heat produced in a conductor is proportional to the resistance or resistivity. So this is also there with the tungsten, that is, it has very high resistivity, and because of these two properties, the filament is made of tungsten and it's capable to produce the heat and light without getting damaged for a longer time. One more thing you should know, within the bulb the gas is also used, that is, the bulb is filled with a gas, that is inert gas called argon, and this is used to prevent the filament from getting oxidized in the sense, like if the heat is produced anywhere, then because of the heat the chemical reaction can take place with the oxygen. So the oxygen and element can react together at a high temperature, and then it can start burning, means it will catch fire. So that is to be prevented. So when the filament is producing lot of heat, then the filament should also be prevented from the atmosphere, that is from the oxygen, so that it will not get oxidized, otherwise it will start burning, it will catch fire. So for this we are using the inert gas called argon. So argon gas is basically isolating the filament, that is tungsten, so that it can produce the heat, it can have high temperature, but it will not catch the fire. So same thing is written here. Argon gas is used in bulbs to stop the oxygen in the light bulbs from corroding the hot tungsten filament. The use of argon in light bulbs prevent the evaporation of the tungsten filament, which results in increased life of bulb. So overall, since it is disconnected from the atmosphere, it is totally isolated, so it will not vaporize also, because we know if the temperature will increase, then solid can be converted into liquid and finally it can convert into vapor, so it can vaporize. So if the filament is isolated from the atmosphere, this process will not take place. So very first, it's not able to oxidize, and second, it is not able to vaporize. That's why we are using argon also in the bulb. So that is all we should know. So in the bulb we have the role of the filament, role of the argon, and that is all enclosed within the glass. I hope it is understood. Next, there are many other appliances which are having the different heating element, and that is able to produce the heat, and we are using in daily life in different ways. Like electric heater we have. So you might have seen in the electric heater there is a coil, and that coil is mostly made up of nichrome, that is an alloy of nickel and chromium, and that can also produce lot of heat. Okay, then electric water heating rod you might have seen, even this has a coil or a filament, the heating element which will produce the heat. Electric press or the iron we have at home, even this is having a kind of heating element plate that gets heated because of the electric current. And electric geyser also, that is also having the heating element which will get heated with the help of the electric current. And there are many other appliances in the market now which we are using at home also, which are producing the heat because of the current. So you can see how the concept of heating effect is being utilized in daily life. So you can search out the heating element of each, like electric heater, the heating rod, means what are the elements and the properties. Okay, So in general, properties of heating elements used in appliances. So when we are going to use any element in the appliances as a heating element, then what should be their properties? So these are the main properties that should be there. The very first, it should have high melting point. We have understood just now. Otherwise it will melt and it will not work. Free from oxidation in open atmosphere, means it should not react that much with oxygen, otherwise it will start burning, so it should not get oxidized easily. Third, high tensile strength. So strength means it should not be able to break down because of high temperature, so the strength it should also be good. Okay. Fourth, sufficient ductility to draw the metal or alloy in the form of wire. So ductility you have understood that can be converted into wire, so it should have this property as well. And high resistivity, so that it can produce the heat. More resistivity, more heat. So these are the main properties that should be there with any conductor which is used in the heating appliances. So I hope you understood. Based on this, we can go for any material which satisfies all these properties. Okay, so let's go for the next topic of this chapter, that is called electric power. And very first you can read out: the electric energy consumed per unit time by any electric appliance is called its electric power. So the only concept is, for example, take the example of the bulb only. So when the electric current is flowing through the bulb, so the bulb is converting the electric energy into heat and light energy. So overall the electric energy is consumed by the bulb and that is converted into light energy. So how much electric energy is consumed by the bulb in a given time, that will be its power. So power is nothing but the electric energy consumed divided by time taken. So more is the electric power of a device, means it will consume more and more energy in very less time. So from this concept we are getting power is equal to E by T, and based on this formula we can find out the SI unit of electric power, that is the SI unit of energy is joule only, time is second. So once we divide, what we'll get? Joule per second, and 1 joule per second is 1 watt. So capital W or watt is the SI unit of electric power. So just take an example, if E is 1 joule and T is 1 second, then power will be E by T 1 by 1, that is 1 watt. Means if a particular device consumes 1 joule of energy in 1 second, we can say its power is 1 watt. And this is the definition of the SI unit of electric power also. So if the question will come how to define the SI unit of electric power, we have to go for this answer. So I hope it is understood. Okay, so for today it's done. That is the only thing we have, the introduction of electric power only, and we'll continue this topic in the next class, because we'll have derivation, we'll have numerical, and next day we are going to complete the topics of this chapter, and then we'll go for numerical only. So based on the class that we have done today, just try some question. So very first question is, if electric power of a bulb is 100 watt, then what does it mean? So if the power is 100 watt, what is the meaning of this? You have to explain the meaning. An appliance consumes 250 joule of electric energy in a minute, calculate its power. So based on the information, if you can find out the electric power, just do it. So we'll continue this chapter. For today is done. Take care. Hari Om.